So today I chose my lesson to be on the dot product of vectors, and basically what we're going to be talking about today is the very basics of the dot product, how to calculate it given two vectors. We're also going to be talking about then how to find angles between two vectors, and then finally how to find what's known as the projection of a vector, which can apply to application problems such as acceleration, speed, that type of stuff. Okay, so what my objective would be is my students should be able to calculate the dot product, the angles between two vectors, and the projection of vectors. So we're kind of encompassing it all in one in this lesson. So to start off, what I would start off with is the definition of what a dot product is. It's basically where you're given two vectors u and v. And basically from there, what you would do is you would just multiply the first term of u times the first term of v, and then add the second term of u and the second times the second term of v. So it would turn into this. Okay, so what I would start off with is I would just start off with finding the dot product of each. So if you're given two vectors, I would label this u1, u2, and the other vector would be v1 and v2. Okay, what I would tell my students specifically is when you do the dot product, you should have a single number. So what I would start off with is I would say, okay, you're going to multiply the first two terms, so it's going to be 3u1 and v1, which is 5. Then you're going to add the second term, so it would be u2, which is 4, and v2, which is 2. And then from there, just simplify. So this would be 15 plus 8, and so you would get 23 for the dot product. That would be the first one. The second one, I would incorporate negatives. So if you had a negative vector, how would it affect the dot product? So it would be u1 and u2. Same thing, v1 and v2. You're multiplying the first terms and then adding the product of the second. So it would be 1 times a negative 4. And then plus, it would be negative 2 times 3. So you were actually going to get a negative. So you would have negative 4 and then minus 6. So that would be a negative 10. What I would tell my students is that affects the direction of the vector. And since it's negative, it would be going like downward in some sort of way. And then the final way I would show my students is what happens when you have I and j. I would say that I encompasses the u vector, and then j encompasses the v vector. So we're just going to multiply, i.e. the coefficients out front. So I would start with that I vector is 2i, so you multiply 2 by the first, or the coefficient in front of I in that second vector, which is 3. And then from there, I would just add, since this is a negative j, it'd be a negative 1, and then times a negative 5. So in other words, you get 6 plus 5, and so that would be 11. So that's how the dot product is done. So then from there, I would just talk about general properties. I'm not going to go through each one of these, but basically I would explain to my students how the properties apply. Biggest properties I would say is if you switch the vectors, they're equal to each other. And if you take u times the vector itself, you would get the magnitude of u squared. And that's what I would talk about. Other stuff just applies when you multiply 0 times a vector, you get 0. And then other stuff would be such things as, associative property, and then also multiplying by a scalar. Okay. But what I would focus on is how do we find the length of the vector? Well, if we're trying to find the length, we're in other words trying to find what's known as the magnitude. So I'm going to actually use property number 2 up there, and I'm going to basically say, okay, if I multiply the u vector by itself, so like this, okay, you can use property number 2, where it's just basically the magnitude, which is the square root of, it's going to be 4 squared plus that second part is going to be negative 3 squared. But then since it's 2 u's, it's going to be, that whole thing is going to be squared. So in other words, this cancels. So you just get 16 plus 9, and so the length of the vector is 25. And that's how you would do that. Okay. I would pivot from finding the lengths and to finding then the angles. So I would talk about when you're talking about the angles between two vectors, you can use the cosine function based upon the sides that you have. So in other words, if you're trying to find the angle between u and v, you're basically finding theta. So I'm going to use this formula up here. Okay, so I would just do a problem like that. So I would start off with, okay, if you're starting with the if you're starting with the dot product, you would do u times v. So it'd be cosine inverse. It would be 2 times 2, or 2 times -2, plus 3 times 5. And then on the bottom would be the magnitude. So basically you just square each part. So it'd be 2 squared plus 3 squared times, it would be -2 squared plus 5 squared. So simplifying that, you would get cosine inverse is going to be equal to, that would be -4 plus 15, and so that would be 11 on top. And then from there over, this would be 2 squared plus 3 squared is going to be 9 plus 4. So it would be, again, 9, 10, 11, 12, 13. And then multiply by 2 squared plus 5 squared, 25 plus, that would be 29. And then just simplifying from there and finding the cosine inverse would be the way. I would ask my students to try these problems, okay, to see how you do. Okay. From there, I would talk about orthogonal vectors. So what does it mean if two vectors are orthogonal? Well, this is what it means. It says if u and v are orthogonal, if and only if the dot product of u and v is equal to 0. So basically what I'm saying is you're just doing the same thing, but then using that special term of what does it mean to be orthogonal. So I would start with prove that the vectors u and v are orthogonal. You would just do the dot product. So it would be what we did before, 2 times -6, first time the first, plus 3 times 4, and you want to question whether or not that equals 0. So from there, I would do -12 plus, this would be 12, and so that would be, in fact, 0 equals 0. So in other words, yes, the vectors u and v are orthogonal. So that's all you have to do. It's just basically another term that we can know based upon the dot product. Okay, and the last term would be talking about the projection of u onto v. I would be talking to my students about how this applies in application problems, how if you throw a ball at a certain vector, where will it, or how far will it go? So basically what I'm talking about is if u and v are non-vectors, we're going to be using this formula. So in other words, notice how the directions are. If you're projecting u onto v, v is going to be the subscore because that's where it's going onto, and u is going to be your starting point. So what we're going to do is we're going to use that formula. We're going to be using u, the dot product of u times v over the magnitude of v squared. And since it's projecting onto v, we want to make sure that that's what it's affecting at the end. So we're going to multiply by v. So I would just do a problem like this. So it says find the vector projection of u onto v. Okay, so here's what I would start off with. What I would start off with is just what is u dot v, okay? So when I do that, I would do just 6 times 5, and then that would be plus 2 times -5. So in other words, that dot product would be 30 plus the -10, which would be 20 on top, okay? The second part I would do is I would find the magnitude of vector v. So the magnitude is just by taking the square root of the two terms squared. But since we're doing in the equation v squared, we don't need that square root because the square root and the square cancel each other out. So in other words, it would just be 5 squared plus a -5 squared. And so that would be 25 plus 25, that would be 50. And so we're just plugging into the formula. So you would have the projection of u onto v would be this. It would be 20 over 50. This is now just a scalar, so it's just a number. But then we're multiplying by the vector of v, which would be 5 comma -5. So I'm just going to simplify as need be. So it would be, this would actually be 2 over 5. And then we could use that property of a scalar from up top, from up here, where we can just multiply the scalar through. So in other words, what would it be? It would be 2/5 times 5 would actually just be 2. And then 2/5 times -5 would be 2. And so that would be your answer. That's the vector projection of u onto v. Okay. So then finally, I would just sum this lesson up with you try this problem. But overall, that's just kind of a start to what the dot product is able to do. My next lesson will be talking about the cross product and how they were different. But overall, that's my lesson for today.